Talk a lot about humidity and weather, but perhaps a more accurate measurement of moisture in the air is the dew point. I explain what this is in this week's Weekly Weather Lab. Moisture. It can be elusive in the Intermountain West, but every once in a while it can feel a little muggy out there. Take last Friday, for example. Tropical air from the Gulf of California streamed up into the region as part of the monsoon. And not only did this bring rain showers, but it also brought some water vapor into the air. But to understand moisture, we first have to understand properties of warm and cold air. Warm air holds more moisture in it than cold air for reasons that are a little bit too complex for this segment. But all in all, this means water is more likely to exist in its vapor state in warm air compared to cold air. A good example of this are the two bowls I have in front of me, with the large bowl holding more water, representing warm air, and the small bowl holding less water, representing cold air. When air gets too cold, the water condenses into clouds or fog, simply because it can't hold the water in its vapor form anymore. So how does this tie into dew point? Well, the dew point is, by definition, the temperature needed to begin condensing out water vapor. Simply put, the higher your dew point, the more water vapor you have in the air. So what exactly makes this a better measurement of moisture in the air compared to relative humidity? Well, if your air temperature and your dew point are very close together, that means your relative humidities are going to be quite high. Remember, cold air holds less moisture in it than warm air, so it doesn't take a whole lot of water vapor in the air in cold air to get high relative humidities compared to warm air. Take, for example, a dew point temperature of 31 degrees with an air temperature of 31 degrees as well. That means your relative humidity is going to be all the way up to 100%. But if your dew point stays the same and your temperature rises up to 90 degrees, your relative humidity is going to drop all the way down to just 12%. Same amount of water vapor in the air, but a different humidity. All because different air temperatures hold different amounts of water vapor in them. And here's a good little graph that explains it all. Dew points in the 60s and 70s feel really muggy out there, but dew points in the 30s all the way even up into the 50s feel pretty dry. Steve, back over to you.